when you think of digital transformation, one of the key aspects is it should be a customer driven, which is nothing but to create a better relationship and better loyalty with customer. One of the technology that could drive this initiative or objective is edge computing. I consider edge computing is designed for digital transformation. So what is edge computing? Edge computing is usually associated with Internet of Things or small network devices. In theory, or if I would like to define it, edge computing places network computing resources as close as possible where data is created. The wiki definition of edge computing is a distributed computing paradigm which brings computing and data sources closer to the location where it is needed to improve response time and save bandwidth. So let's think it for a second. Where does the data come from? We often think data exists in cloud where we do AI and analytics activity. But that's not where data is created. Data is created by us, the human beings, in the environment we operate in, the places we do work. It comes when we use device or equipment, and it comes from the equipment itself and is produced of byproduct as use of the equipment. So let's take it down a little bit further. We have seen earlier that in cloud computing delivers over internet. In earlier days, it was only PCs which were accessing these computing resources in the cloud. But more recently, you see smart devices, IoT devices, utilizing the cloud resources. For example, connecting cameras over internet has given rise to a smart home and smart factories. But one of the bottleneck is when you try to transfer high load of data, high resolution video or picture, which could cause network latency and could cause delay in response. And this is one of the reason for the rise of edge computing. With edge computing, the devices will now process some of their own data rather than relying it on cloud. It makes the system and application more efficient by removing the components data services from a centralized server and placing the data closer to the edge. So before we get into detail, let's look at some of the definition. Typically in edge computing technology landscape, you will hear the following term: edge devices. This can be any devices that produces data. It could be a sensor, industrial machine, routers, WAN, switch, etc. Next is edge server. This could be a server, maybe a half rack of 4 or 8 blades. It could be an industrial PC, but it is a piece of equipment which was built with the purpose of computing IT workload. The edge servers are also called as fog computing. This term, fog computing, is coined by Cisco. So fog computers are resources which are close to the computing devices and between edges of network and remote cloud. So for example, it could be that in a factory some edge computing resources or sensors are communicating with local fog resources, which in turn communicate with the cloud data center. Let's understand with an example of a self-driven autonomous car. Safety is always the first concern of connected and automated car. Driverless car need to ensure that they are keeping to their lanes, recognizing and stopping at the red light, slowing down when identifying a pedestrian and other obstacles, and much more. All this require a massive amount of sensory data in real time. The car need to send terabytes of data to the central server and then receive the response and then act. In case of any mishap, the car needs to take a crucial decision. If we send such a massive amount of data to the centralized cloud server to process and get the response, it can result in disaster, as it is not fast enough to respond to the immediate dangers in real time. In such scenario, edge computing can help. Edge computing reduces strain on the network and provides better reliability by reducing the time lag between the data processing and transferring the data to the vehicle. It can perform data analytics and speed up the analytic process, allowing the driverless car to take instant action. So what is driving this edge computing? Edge computing is emerging mainly for two reasons. The first is because of rising pressure on network capacity. And the second is demand to get faster and faster response from AI and other related real-time applications. And what are some of the use cases of edge computing? Edge computing is used in video conferencing, for building up smart cities, oil rig in the ocean. For example, oil rig has thousands of sensors producing a massive amount of data, and most of them are not important, but determines that the system is working properly. So it is not necessary to send every data over the network as soon as it is produced. Instead, the edge computing system can compile the data and send daily reports to the cloud for a long-term storage. By sending important data to the network, the edge computing system reduces the data traversing. It can even help in predictive maintenance to identify the potential breakdown before they impact the production. And some of the top companies that are using edge computing are Amazon, Dropbox, and GE. So it's interesting to note that while for a decade we have been pushing computing power out to the cloud, increasingly we are also pushing it opposite direction to the local devices. So does this mean that it's an end of cloud era? Well, no. Edge computing doesn't mean the death of cloud era. Edge computing is more of a complement to the cloud computing. It can't replace the cloud computing because there will always be a need for central processing. It needs a cloud to configure, deploy, and manage IoT devices for analyzing large data set from different data sources. It makes sense to perform IoT analysis at the edge when an instant action is needed and for a faster data processing. But the data will likely need to be collected and centrally stored. Ultimately, cloud computing will remain an integral part of any edge computing environment. Thank you.